Okay. So as we have already discussed the concept where we are like exclusively we were using the concept related to sum of the roots, product of the roots. Let's take one question and let's see how to do this type of question. So when we are having here Rishita, are you from class 11? Am I
Yes,
audible?
ma'am. I was the last lecture.
Okay, you was there. Okay, let's start. So if I'm taking the question, let alpha and beta be the roots of equation px square plus qx plus r is equals to 0, where p not equals to 0 if p and q, p, q and r are in AP and 1 by alpha plus 1 by beta is equals to 4, then the value of mod of alpha minus beta, that means absolute value of alpha minus beta, is option A root 61 over 9, option B 2 root 17 over 9, root 34 over 9. Yeah, so these are the given information. Here it says alpha and beta are the roots of this equation. Alpha and beta is the root of this equation. So since we know alpha and beta is the root of the equation, we can find the sum of the root and the product of the root, right?
Yes, ma'am.
Yes or no? So can we write the sum of the root, like since the quadratic equation is px square plus qx plus r is equals to 0, what will be the sum of root alpha plus beta?
Minus Q by P.
Yeah,
Minus Q by
perfect. And what will be the product of the root?
R by P.
Yeah, c by a. Okay, we know the sum of the root, we know the product of the root. If P, Q, R are in AP, so they are in arithmetic progression. So if P, Q, R are in arithmetic progression, then what can be written for mean?
For what?
For mean, mean, arithmetic mean, there is a relation, right? If A, B, C are in arithmetic progression, then A plus C by 2 is equals to B, right?
Yes, ma'am.
Similarly, can I write P plus R over 2 is equals to Q, which says that P plus R is equals to 2Q, right?
Yes, ma'am.
Let's give it a equation. Like this one is equation number 1 I am saying, and this one is equation number 2. Now what we have to find here? We have to find we are also having one relation which is given over here, this one. Okay, So let's take that relation. Let's take that condition that 1 by alpha plus 1 by beta is given as 4. So can I say it will be beta plus alpha by alpha beta is equals to 4 if we are taking the given condition. Can we simplify it like this? We know alpha
Yes,
plus
ma'am.
beta is what?
Yes.
In equation number 1 minus q by p, right?
Yes, ma'am.
And alpha beta is r by p. So if we will be substituting it over here, minus q by p by r by p, what are we getting? Can you tell me?
Minus Q by R.
Perfect. Is equals to 4. So these are what are we having? Few conditions, few equations, few relations we are having in hand, and we are keeping it aside. Maybe while finding modulus of alpha minus beta, that means absolute value of alpha minus beta, maybe for finding that, these informations, these equations will help us. Okay, so now we have to find mod of alpha minus beta. We know there is a relation which says alpha minus beta whole square is equals to alpha plus beta whole square minus 4 alpha beta. Do you know this relation?
Yes, ma'am.
Uh,
Okay, it's just the
no.
identity of a minus b whole square
Yes.
is equals to a plus b whole square minus 4ab. Because we are asked alpha minus beta, so we are using this relation and we are having in hand the sum of the root, the product of the root. So let's see whether that's helping us or not. So alpha plus beta whole square. What was alpha plus beta? Minus q by
Q by
p
minus Q by P.
minus 4 alpha beta. That means 4 into
Minus
r
4
by
R
p.
by P.
Let's simplify it further. So we are having q square by p square minus 4r by p, right? Let's see whether the informations which we are having in hand is going to help us or not. This p plus r is 2q and this one is 4. So if we will be going further, then what can be written over here? Can I say this is giving us minus q is equals to 4r. That means if we will be doing squaring both side, then q square is equals to 16r square. Can we say?
Yes, ma'am.
Let's substitute it here. And one more relation we are having in hand, that is p plus r is 2q. Anything else? No. If we will be taking p from here, here the values options are given in values. So obviously we must get a value. We have taken sum of the root, product of the root. A plus c. Let's see what can be done here. If we will be having the LCM p square, here we are having 16r square and here we are having 4rp. This 4 is not helping that much. Just a moment now.
Okay.
Here we are getting Q is equals to, already we are having Q value. What will be P value? If we are having here P plus R is equals to 2Q by arithmetic mean condition, then P plus R is equals to Q is minus 4R. We are trying to keep Q and P in terms of R, then we are getting here is equals to minus 8R minus R, that means minus 9R. So I can say P is minus 9R and Q is only minus 4R. Will it help if everything I'll be converting in R? So here in our simplified form, if P is minus 9R and if Q already I have substituted minus 4R, P value again I am putting here minus 9R. Will it help? Why we are doing R? Because we are not able to calculate the value over here. Okay, once Q is there, P is there, R is there, a lot of different variables are there, then it is not getting possible for us to reach the option. If you can see, option doesn't contain P, Q, R. Okay, so we are trying to get a value out of it. And once Q already I have substituted, P also in terms of R if we are substituting, then here we are getting 16 R square plus 9 4 times 36 R square divided by 81 R square. Can you see? Are you getting it?
Yes, ma'am.
This relation came from the AP condition, which we were having in hand, this one. P plus R is equals to 2Q. Here we have substituted our Q value, that is minus 4R. So basically, whatever informations we are having in hand, maybe that will help us to reach a value. Okay. Now we are having 16 R square and 36 R square, 6 6 12, 314, 152 R square. Is it clear so far?
Yes, ma'am.
Yes, ma'am.
This got cancelled and we just got rid of just variables. We wanted to get rid of variables and here we have done such a substitution that we ended up getting a value 52 by 81. This is alpha minus beta whole square. Alpha minus beta will be under root of this one plus minus root of this one. But we have to find modulus of alpha minus beta. That means we have to take the positive value from here, not the negative one, right?
Yes, ma'am.
Do you know that modulus means what?
Yes, ma'am.
We have to take the positive root 52 by 81. Let's try to simplify it. Root 81 means 9. 52, if we will be simplifying it, let's see 52 is there in option or not. No, it's not there. So if we will try to simplify it to 1 times to 2 times 4 to 6 times 12, right? To 1 times 2, 3 times.
2 root
So
13.
2 root 13 by 9. Let's see any option is like that or not. So can you see fourth option is the correct option?
Yes, ma'am.
So basically what are we doing? Whatever information, first line says this is a quadratic equation. Sum of the root, product of the root, bare minimum, that much we can do and we can keep it aside. The second statement is saying AP. So AP, we know the condition that the sum of the first and last term will be equals to twice of the second term. This much we know from the arithmetic sequence, arithmetic progression, which you have done in the previous class only. And here one more relation was given, 1 by alpha, 1 by beta is 4. So that also we are trying to simplify it, and then we are finding the value of alpha minus beta. By using all the informations, you have to keep it in one place so that quickly you will be able to use it. Okay,
Yes, ma'am.
let's move ahead. Any doubt over here?
No, ma'am.
Mm. Ma'am, can you go up? I didn't copy the last part.
Yeah, sure. Here, this much.
No, a bit more up. I copied that part. Yeah, a bit more down. The P plus Q, that part. Yeah,
Is
just
it
a bit more up. Yeah,
okay? Okay, do let me know if I have to drag up or drag down.
now can you drag down?
Is it okay?
Yes, ma'am. Can you drag down?
More?
Yes, ma'am. Down now.
Done? Or
Yes.
more? So are you doing it, the downward part, or done?
Yes, ma'am.
Okay, do it and let me know.
Ma'am, I'm done.
Okay. So the next question says if ABC are the sides of a triangle ABC such that x square minus twice a plus b plus c x plus 3 lambda ab plus bc plus ca is equals to 0, has real roots, then we have to figure it out which condition is the correct. Lambda is less than 3, lambda is greater than, okay, it's not 3, it's less than 4 by 3, is greater than 5 by 3, lambda belongs to this open interval 4 by 3, 5 by 3, or lambda belongs to open interval 1 by 3, 5 by 3. These are the given option. Let's go through the question first. Okay, A, B, C are side of a triangle. We are having this type of triangle. A, B, C triangle whose sides are ABC. Whenever such triangle is given whose sides are ABC, then you must take opposite to A side A, opposite to B side B, and opposite to C small letter side C. This way we have to take whenever it's talking about triangle ABC and sides are also ABC. Okay.
Yes, ma'am.
Now for this triangle, there is a rule, the cosine rule and the sine rule. So do you know cosine rule from here? Anyone from both of you?
No, ma'am.
Okay, just let me write the rule first, then we will be moving ahead because we have to use that rule over here. So just a moment, let me write the rule. The rule says cos A for this triangle. Okay, this is not isosceles triangle. This is not right angle triangle. This is not like equilateral triangle. This is just a triangle. It can be like two side can be same over here, can be different, but for this type of triangle which is not a right angle triangle, usually whenever we are talking about sine, cosine, and all the trigonometric ratio, we talk about the right angle triangle. But what if in the question right angle triangle is not given, then we are having certain formula, the sine formula and the cosine formula. Here we are going to use the cosine formula. That's why I am going to write the cosine formula directly over. Like in class 11 only you will get to know about that cosine formula. Okay, so the cosine formula says cos of angle A is equals to B square plus C square minus A square by 2BC. Cos of angle B is equals to A square plus C square minus B square by 2AC. And cos of angle C is equals to A square plus B square minus C square by twice AB. Okay, these are the cosine formula for finding angle A, angle B, or angle C, whatever is required according to the formula. We just pick the formula. If angle A we have to find and all the sides are known, this is the formula which can be applied to find angle A. Instead of A, if B angle B we have to find, then this formula can be used. Instead of B, if C is asked in the question, then this is the cosine formula which we need to use. So when sides are known and angle we have to calculate, this formula will help us. Now, what we have to do here, one more thing we must know whenever we were talking about the class 10 concept, the ratio, trigonometric ratio, sine, cos, tan. So that time you have seen that if we are having a right angle triangle ABC, then cos is what? Cos of cos theta is adjacent over hypotenuse, right?
Yes, ma'am.
That time you have learned that cos theta is adjacent over hypotenuse when we are having right angle triangle. So if let's say this side is 3, this side is 4, and this side is 5, so adjacent is 3 and hypotenuse is 5. When you will divide this one, like when you will divide 5 this 3, when you will divide this 3 by 5, Are you getting that we will always get 0 point something, a number which will be less than 1? Because hypotenuse is bigger. So you are writing the bigger value in the denominator always. While finding any cos theta, we were always writing the hypotenuse in the denominator, and we know hypotenuse is greater than, it will always be bigger than adjacent side. Yes or no?
Yes, ma'am.
Whenever you are dividing a smaller number by a bigger number, you will always get a value less than 1. Okay?
Yes, ma'am.
Yes,
So
ma'am.
similarly, here we can say this one, since we are talking about cosine, even if the formula is getting changed, but the value will be less than 1. This one will also be less than 1. This one will also be less than 1. Why? Because here we got to know that cos, whatever we will substitute as a adjacent and hypotenuse, always hypotenuse will be bigger and cos will be less than 1. That concept we are using in here for different triangle, but since we are talking about cosine only, that cosine, this cosine is same, condition is different. Okay, so now let's get back to the question. This much information we are having in hand, we will be using it. Now let's see the question. If ABC are sides of a triangle such that this has real roots, so this looks like a quadratic equation, yes or no? Ax square bx and c is equals to 0, right?
Yes, ma'am.
So if we will be taking this quadratic equation, that is x square, if we will be taking this quadratic equation, that is x square minus twice a plus b plus c x plus 3 lambda ab plus bc plus ca is equals to 0. Do you know that whenever the quadratic equation has real root, there are three conditions. Discriminant, that means b square minus 4ac is greater than 0. Disc discriminant, that means b square minus 4ac is equals to 0, and discriminant, that means b square minus 4ac is less than 0. These three conditions are there for quadratic equation. Here the first condition says if discriminant is greater than 0, then we will be getting two real roots. Okay, two unequal real root. If discriminant is equals to 0 you are getting, then you can say this quadratic equation will have two same real root. Same or equal you can say. And if discriminant is less than 0, then you can say this quadratic equation will have no real roots. These are the three formulas, three rules. Whenever I am writing a quadratic equation, let's say x square minus 5x plus maybe 6. If I am writing like this, then I will be asking you what is the nature of root. Whether without solving it, tell me how many roots you will get and whether both the root will be real or not real or same, or what is the nature. So we see the people, have you seen uh, astrologers, they just see the face and they try to tell that you are having this in hand, you will be doing this in futures and all, right?
Yes, ma'am.
So
Yes, ma'am.
just by looking at the face, they says a lot of things. They have, maybe they have gone through a lot of books and a lot of theories which says that if a person looks like this can be the possibility. If a person is having this mark, then this can be the possibility. Similarly, we are saying in mathematics, if we are having a quadratic equation, we can, without even solving the quadratic equation, we can say what will be the nature of the root. Still, if you don't understand what is the meaning of the root, root means solution, x value. We will be getting 2x value. Both the value will be real number. same real number or not real number, imaginary number. How we will say that without even solving or touching the equation? So three rules are there which says just go and find b square minus 4ac, and if your b square minus 4ac is greater than 0, then you will be getting two real unequal root. If your b square minus 4ac is equals to 0, then you will be getting two same real root. And if your b square minus 4ac is smaller than 0, then you will be getting no real root. That means imaginary root you will be getting. Okay.
Yes, ma'am.
This is the concept. We are going to use it over here. What's the need of using it over here? Till now we were just so comfortably we were using the concept of the sum of the root and the product of the root, or just all of sudden how come we started using this rules and all. So if you will go through the question, it says such that this equation has real root. Can you read it? It says that it has real root. So whenever any quadratic equation is talking about real root or imaginary root or same root, this is the formula, this three formula we are having in hand which we need to use. Since it is talking about real root, if you will look at the formula, the first one is giving real root or the second one is giving real root, right? Third one is giving not at all any real root, right?
Yes, ma'am.
And the
Yes, ma'am.
combination of first and second rule will be b square minus 4ac will be either greater than 0 or equals to 0. Because the question is talking about real root, it can be first case or can be second case, and the combination of both the rule will be greater than or equals to inequality sign. Is it okay?
Yes, ma'am.
So
Yes,
let's
ma'am. Can you
let's
show
see
the
our quadratic.
question again?
Yeah, what?
The question.
See the question. If ABC are the side of a triangle ABC such that the quadratic equation has real root. Real root can happen when discriminant is greater than 0 or when discriminant is equals to 0. Now you are in class 11, you must have done inequality chapter. There you must have seen this greater equals to sign, less equals to sign, right?
Yes, ma'am.
So that's why I am taking the combination of first and second rule, that means greater or equals to sign. So our question is, our quadratic equation is x square minus 2 times a plus b plus c x plus 3 lambda. Just a second now.
Yes, ma'am.
So yeah, we will be taking the condition that the given equation 3 lambda AB plus BC plus CA is equals to 0. Here we will be using the condition, this one. B square minus 4AC is equals to 0. Is greater or equals to 0. As you can see, this is B. Okay. The quadratic equation looks like ax square plus bx plus c is equals to 0. You know that, right?
Yes, ma'am.
Yes, ma'am.
We will be taking this condition. Apart from taking this condition, we will also be using the cosine rule, which I told you. So first, take b square minus 4ac is equals to 0 and write it over here and see what you are getting after doing the simplification of the inequality. After that, this one I am leaving for you. You will be doing it, okay? After that, the cosine rule, please check it again. B square plus c square minus a square by 2bc. Other one is a square plus c square minus b square by 2ac. So from here we can say that b square plus c square minus a square by 2bc is less than 1, which implies that b square plus c square minus a square is less than 2bc. Okay, cosine we are leaving it, keeping it aside, and the formula is less than 1. So we are getting this relation from here. Similarly, the next formula was a square plus b square minus c square by 2ab less than 1. We will be getting the same thing just like the first one. And the next one is ab, bc, ca. Here also we will be getting the condition. So we have to use equation number 1, equation number 2, equation number 3. Just do this much, b square minus 4ac greater or equals to 0, and do let me know what are you getting. Okay, and give me a second. Okay, can you
Yes,
see the
ma'am.
screen?
Yes, ma'am.
Yes, ma'am.
So do Have you done this?
Doing, ma'am.
Yeah, what you got? Okay, doing it.
Yes, ma'am. Doing.
So let me write. You must have got this 2a plus b plus c whole square. That means 4a plus b plus c whole square minus 4ac. 4 into a is just 1 and c is 3 lambda
3D. Yeah.
a b b c c a. Everything you must have got greater or equals to 0 here. This 4, if you will shift this totally, the subtraction part to other side, it will be 4a plus b plus c whole square is greater or equals to 4 3 times 12 lambda ab bc ca. This 4 and this 12 will cancel out each other and we'll be having 3 lambda over here. Now we can go ahead and we can expand this a plus b plus c whole square. A square b square c square 2ab 2bc 2ca like that. So a square b square c square plus 2ab plus 2bc. Why I'm 2ab 2bc 2ca I'm taking? We can send it to other side. Okay, and we can simplify it further. So let's send it directly to other side. We will be having 3 lambda ab bc ca. Here we will be having minus 2ab minus 2bc minus 2ca. Is it clear so far?
Yes, ma'am.
Is it clear? Now here from this 3 relation we will be having 2ab 2bc 2ca. If we will add this 3 equation, we will be having a simplified form. Please note it down. Are you noting it down?
Yes, ma'am. Done, ma'am.
So this 3 relation we will be adding equation 1 2 3 and we will be getting a relation from here. If you will add all of them, I am showing it here only, you will be having this a square will go, this b square will go, right? So what are we having? We are having 1a square. Okay, c square will also go. This c square will go. Can you see?
Yes,
So
ma'am.
we are having 1a square, 1b square and 1c square. That is less than 2ab plus 2bc plus 2ca. Okay, we will be using this relation and this relation. At the place of a square b square c square, you can write this one. Okay, please use this two relation to check what is the like lambda range. Is it less than 4 by 3? Is it greater than 5 by 3? Like this. Will you be able
Okay.
to try it by yourself?
Yes, ma'am.
Do try it, okay? This relation and this relation will help you. Whatever substitution is possible, just do it. Okay, so these were the concept. Here, if you have noted down the concept, well and good. If you have not noted down this concept, which I have written related to discriminant and all, I'll be